Let's take a look at maximum subarray. Given an integer array nums, find the subarray with the element next to each other which has the largest sum and return its sum. Okay, let's take a look at the examples. Let's try to understand the problem. We need to find a subarray containing at least one number. Okay, and all the elements must be next to each other. The output is 6 because the subarray is this one. We have 4 plus minus 1 plus 2 plus 1 equals 6. What it means of having all the elements next to each other, it means that we cannot just, for example, pick this array, this subarray plus this one. No, if we want to do that, we need to include minus 5 as well. Example 2, we have only one option. And example 3, we see that if we sum all of these ones, the sum is 23. Let's take a look at the brute force solution, and then we will directly jump to the more efficient solution. We have two for loops to go over all the different indexes. So for example, the first one, I, is this one, and J will do this one and then this one and go over. And what we'll do is we are computing the sum between I and J. So at the beginning it will be minus 2, and then it will be minus 2 plus 1, and then it will be minus 2 plus 1 minus 3. So this is what this line is actually doing. We could think that the complexity of this code is n squared, but it's not. The reason it's n cubed is because sum, like the line 7 here, is also taking order n. In order to do the sum, internally you need to compute and to go over all the elements. So it's like we have one for loop inside another for loop inside another for loop, and all of them are taking O of n. So the overall time complexity is O of n cubed. Now let's take a look at the more efficient solution. To answer this question, we'll need to ask ourselves, is it better to add the number to the previous one or to actually start from scratch? The reason we need to ask this question is because we need all the numbers from the subarray to be next to each other. So sometimes it might be better, for example, in that case, to keep 4 plus minus 1 plus 5 equal 8. But sometimes it's better, for example, to not include minus 3 and to actually start here at 4. So let's initialize the value at minus 3 because we know that it contains at least one number. So let's start with 4. The question that we need to ask for both the current sum and the max sum is it better, so we have minus 3, right? Is it better to do minus 3 plus 4, meaning we add the 4 to the minus 3, or to start from scratch? In that case, it is better to start at 4 because 4 is bigger than 1. Now let's do the same for the max sum. So we have minus 3, right, so far, and we do, should we take minus 3 or the current sum, which is 4. So we have max sum equal 4. Now we continue with minus 1. So we have, is it better to do 4 minus 1 or just minus 1? So it's better to do this, and now we have still, for the max sum, we have 4, between 4 and 3 is better to do with 4. Now we do the same with 5, so we have the option 3 plus 5 equal 8 or just 5, so 8 is better. And now we have 4 or 8, so we go with 8. And now minus 7, so 8 minus 7 equal 1, or just -7. So we actually go with 1, but here you see that the max sum between 8 and 1, we go with 8. So at the end of the algorithm, the output will be 8 because the max sum is equal to 8. Now let's see with code, and you will see that it's actually pretty easy to understand and to code. We said that we have two variables, current sum and max sum, which will be equal to the first element of the array nums. Now we want to go over the array. So for I in range 1, we start at 1 because the number 0 is already taken here. 1 until the end of the array nums. Now what do? We said that current sum, we asked the question, is it better to start from scratch, meaning we start at nums the I, or we add to the previous one? So we have current sum plus nums of I. And now kind of the same for the max sum. We ask, is it, which one is higher? Is it max sum or is it current sum? And that's all. Now we return max sum. So let's see how that works. Okay, and submit. Perfect. So now let's talk about the complexity. We see that here we only do one for loop. So we have O of n for this one. Here we just do a simple comparison. We don't do anything crazy, so it's all the same. So let's see. Complexity, we want the time and the space. We just said that the time is O of n, and the space complexity, we don't store any array, we don't do anything crazy, so the space is actually O of 1. So you saw that the question is pretty simple. The solution, once we understand how it works, to ask ourselves, is it better to add the value to the previous one or to start from scratch? It's actually not super hard to understand. I hope that was helpful, and yeah, see you for another LeetCode. Peace.